This presentation is about the effects of steady-state exercise on the body system. Steady-state exercise is when the body is working at a steady state. This means that lactic acid removal is occurring at the same time and pace as lactic acid production. How is the cardiovascular system affected by steady-state exercise? Straight volume is affected by steady-state exercise as the greater amount of blood supplied to the heart. This will stretch the cardiac muscle. Due to the stretch in the muscle, a greater contraction occurs. As a result, more blood is pumped per stroke. This is known as Starling's law. Thermoregulation. The body core temperature is 37 Celsius. Variations in the core temperature just by 1 Celsius can affect athletes' performance. This is controlled by cardiovascular system. Vasodilation. This is how we cool down. Vasodilation is when the blood vessels dilate, and this allows blood to pass closer to the skin, which then results in us sweating. And as we sweat, this will cool us down. On the other hand, vasoconstriction is when the blood vessels constrict and blood passes to all the major organs when you're cold. Heart rate. Heart rate when doing a steady exercise will start to increase during and then level out as it meets the demands of the exercise, and less blood is required to be pumped out as it already knows the demands that needed. Blood pressure. Blood pressure is dilation of the blood vessels supplying to it to muscles. This decreases the blood pressure. In contrast, cardiac output increases, counteracting this. The respiratory system. Tidal volume is the amount of oxygen intake in one breath. Tidal volume increases to a certain point and will level out. As you can see from my diagram, that's what I've shown. This increases because our body needs more oxygen as we are working harder. So you increase the depth of your breath, increases, so more oxygen is brought in each breath and more CO2 is exhaled. Breathing rate. Breathing rate is the amount of breath you take in 1 minute. Breathing frequency increases to a certain point and then levels out, as I've shown on the diagram. This happens because it has to meet the demand of exercise to bring in oxygen and get rid of carbon dioxide. The oxygen dissociation curve. As you can see from this picture, this is an example of an oxygen dissociation curve diagram. Oxygen reacts with hemoglobin to form oxyhemoglobin. How much oxygen bonds to hemoglobin depends on the partial pressure of oxygen. For example, when the oxygen is in the lungs, it is in a high concentration. All oxygen attracts to hemoglobin, and then the oxygen gets to the muscles. They detach as in a low concentration. When the carbon dioxide and pH levels change, it can shift from the left or to the right. This happens because the higher the levels of carbon dioxide, the higher the acidity, is what makes the curve move to the right. When there are low carbon dioxide levels, there is less acidity, which means the curve goes to the left. Just like carbon dioxide, temperature also makes a big difference to the core. The warmer the place, for example, your muscles, the more oxygen will be dropped off, meaning the curve will move more to the right. Neuromuscular system. Pliability. Pliability is when the muscles warm up and become more pliable. Therefore, this is giving them a greater stretch without tearing. Speed of transmission. As muscles warm up, the rate of nervous impulses increases. As the heat increases, the speed of transmission also increases too. The aerobic system. This system reduces most of the energy supplied to the body. It is slow to produce but highly productive. Aerobic glycolysis. When oxygen is present, glucose is broken down. It is broken down to pyruvate. As the oxygen is present, it enters a series of reactions, the Krebs cycle. Pyruvate combines with coenzyme, a CoA, to form alkylate CoA, producing ATP, hydrogen, and carbon dioxide. The electronic transport chain, hydrogen atoms form Krebs cycle either to enter the chain, pass along, combine with oxygen to form more ATP. As you can see from this diagram, this is the electronic transport chain. This all takes place in the mitochondria. The mass amount of folds give a large surface area for energy production to take place. These folds are called cristae. As you can see from this picture, these are the mitochondrial structural features.